So the title of my talk, 10,000 Years of Lithic Procurement in the Taos Valley of northern New Mexico. And I chose this slide, as you'll find out in a couple seconds. I'm not actually going to be talking about a field project that I've done. In fact, the field project and the collections that I'll be talking about were made when I was still playing with He-Man toys and G.I. Joes in a sandbox. But in 2021, we were out in the field. So this gives you two things. It gives you an idea of the environment that we're working in. And if you look in the distance, you'll actually see all three of the obsidian sources that I'll be mentioning today. The Valles Caldera, or the Valles Rhyolite, or Serra del Medio, Serra Toledo, or Obsidian Ridge, or Rabbit Mountain, and El Richuelos, or the Polvadera obsidian source. Let me see if I screw this up. There we go. So what I'm going to be talking about today is the Taos Valley Settlement Survey.
Just going to try and pull that up your screen again. Sorry about this.
Yeah, that's all right.
Maybe.
There we go. The Taos Valley Settlement Survey. This was a project started in 1981 by an archaeologist out at our campus in Taos, SMU in Taos, or the Fort Bergman Research Center. It was started in 1981 and it ran from 1981, 2, 3, 4 field seasons. And then that faculty member left. The project was picked up again by a graduate student named Jeff Gerard in 1986. And then again by a graduate student named Shirley Kuntz in 1988. And since that time, nobody has picked it up again. This was a pedestrian survey that covered about 100 square kilometers, which is a pretty big area. You can see all of the sites and isolated finds and the survey areas in yellow on the screen. Let's see if I can do this. Well, right over here. So the yellow boundaries are the survey boundaries. Orange dots are sites that were identified during this survey, and blue squares are isolated finds. I've abbreviated them IF here just to save space. The survey ran from SMU in Taos's campus on the far south end of the valley to the Arroyo Hondo Valley in the north end. And during the course of the first 4 years of survey, folks identified about 500 sites and over 1,000 isolated finds. I say over 1,000 because we don't know exactly how many were found, because the documentation for these, as you'll see in a second, is quite poor. From each site, there was a representative collection of artifacts that was made, including debitage, diagnostic points, etc. And all of the isolated finds were picked up. Go.
Sorry, sometimes you have to
Try
it out.
Hey, there we go. So between 1982 and 1984, most of the artifacts that were collected were preliminarily inventoried. Counts of different pottery types, counts of different projected point types or debitage types, but no detailed analysis of anything that was picked up. And all of this cataloging was done on 5x7 index cards. It's still on 5x7 index cards. Have you ever tried to sort, say, artifact types across 500 different sites, 100 square kilometers, sort all the obsidian with index cards? Think about how many index cards that is. It's literally boxes of index cards. It's impossible to find anything. And most of the work focused on ceramics because this is the US Southwest. I'm not a Southwesternist, I'm a Easternist. So I like lithics. But I'm learning that my Southwestern colleagues don't like lithics at all. They prefer pottery because pottery is artsy, you can tell time with it, all sorts of other things. So most of the lithics that I'm passing around and all the stuff that I'm be talking about has largely been ignored. And to compound issues, at least from my perspective, virtually nothing of this survey has been published. There's one publication from 1986, which is kind of a bird's eye view of the results of the survey. Now, I mentioned Jeff Gerard and Shirley Kuntz. who did work in 1986 and 1988 respectively, they actually prepared reports for the Forest Service, and they're good reports. But they were only surveying about 10 to 15 sites. So they're manageable, completed things. And perhaps I think the greatest problem with this survey is that absolutely none of this information was ever provided to the New Mexico State Historic Preservation Office. So that means that since 1981, we've known that sites exist in certain areas, but nobody else does outside of SMU and Taos and those 5x7 index cards. So in 2016, when I got to SMU, I spent my first year teaching. I didn't do a lot of research. I kept my nose down. I tried to stay out of trouble. And then I started asking questions, and I found out about this project. Found out about a number of different projects. And so this one kind of took a back seat because it was so big. But we have records and artifacts from this project. We have a poorly studied project. We have this big scale survey, which is huge, a big, massive data set that we could do a lot of really cool stuff with, but nobody has done much with it. And at least where I'm from, that means that we, even if I didn't do the survey, even if I never thought about this, let's see, 5 years old when the survey started, still playing with E-Man and G.I. Joe. I'm at SMU now, it means that this survey was done by SMU, it's part of my ethical obligation to do something with this. And if you know me, most of you don't know me, but if you know me or if you read most of my stuff, when I find a problem that needs fixing, that's something I get excited about. And it just so happened that in 2020, we entered into the COVID pandemic. This is a perfect project for working on during a pandemic. We already have the stuff. There's no reason to go out in the field. There's no reason to do anything else. We already have all the records, the artifacts, etc. It's time for us to sit down and get to work in the laboratory. And so that's what I did. We brought all of the fine-grained volcanic stone and fine-grained or volcanic glass, obsidian, back from Taos to Dallas. And I sat down and I inventoried all of those pieces. I chose the fine-grained volcanic rock, FGV if you prefer, and the obsidian, the glass, because it plays into my strengths. I'm a geoarchaeologist, if you will. I have experience doing chemical analyses of things, and fine-grained volcanic stone and obsidian works really well for what I like to do. It's not the only thing I like to do, but it was something I could easily make a dent in very, very quickly. So we inventoried them, we analyzed the stuff, we assigned them to known and unknown sources when we could. And in 2022, we began to digitize all of the site records and all of the artifact records to build a database. And I currently have a volunteer who is at SMU here in Dallas, who's going through all of the other lithics, the cherts, the jaspers, the chalcedonies, etc. And because I like to present work before I publish it, because I feel like it's an obligation to the public to talk about my work, you are the first people outside of my office to see these results. Nobody else has seen them, they haven't been published. They're still kind of preliminary, but I don't know how good they are. You can tell me afterwards. I'm workshopping it with you guys. So what types of stuff am I talking about? Primarily, when I say fine-grained volcanic glass, I'm talking about obsidian. Obsidian's predominantly silicon, Si. It has a felsic or rhyolitic composition. That means it has a lot of potassium and sodium. And it forms when magma of this particular chemistry cools very, very quickly. It hits a glacier, it hits a lake. It cools almost instantaneously, faster than minerals can form. And we have a related rock that we call rhyodacite. Rhyo from rhyolite and dacite from another volcanic rock, dacite. The name is because it's intermediate between these two kinds of rocks. It has a lower silicon content, So if you look at some of the projectile points that are being passed around, a lot of those are this rhyodacite. It's a very fine-grained, dark, glassy kind of rock. After inventorying all of the stuff that we brought back, we have 515 pieces of obsidian debitage or tools, and we have 135 pieces of rhyodacite, either tools or debitage. So that gives you an idea of the size of the sample. Now, remember, I told you at the beginning, we were looking south in the distance, and you actually are looking at these three obsidian sources, and we're, oops, up here, looking south at those from that first photograph. Looking at those obsidian sources, they're the closest ones that we have to the area that this stuff was picked up in. There's another one, another obsidian source way up here on the Taos Plateau, almost to the Colorado border, that's called No Agua Peaks. You speak Spanish, that means no water. And a more apt name you could not want. Okay. But the obsidian there, despite being the closest, is actually really crummy. It has a lot of stuff in it, it doesn't flake very well, and the nodules are about the size of golf balls. If you've ever tried to make a projectile point out of crummy material, working with a nodule the size of a golf ball, maybe the size of a tennis ball, you would just give up. It's worth it to walk the 20 extra kilometers south to these other sources, because you get larger blocks, larger pieces that you can work with. Probably the most known, at least out here in Texas, is the Cerro Toledo or Obsidian Ridge, also called Rabbit Mountain. There's a number of different names. It's most widely known because it's most widely distributed. And we find that obsidian basically on the entire eastern flank of the Valles Caldera, that central extinct volcano that is more or less where Los Alamos National Laboratories is. Santa Fe is just over the other side of the river. And all of this obsidian is eroding from this caldera into the Rio Grande. And you can fish Cerro Toledo obsidian out of the Rio Grande as far south as El Paso. That's how much there is of it. There's a problem with it, though. It has these little pockets in it, these little non-glassy pockets that when you're flint napping it, you don't see them because it's black glass. And so if you are working all day on a beautiful Clovis point, and you're about ready to chip the last couple bits off of it, and you hit one of these pockets and the entire thing explodes in your hand, you're going to say a couple of cuss words. Another source, which I think, and other folks who have napped it think is probably the best, highest quality material in the Jemez Mountains, is the El Richuelos obsidian, also called the Polvadera Peak obsidian, although that's a misnomer because it's named after the wrong spot. There's no obsidian at Polvadera Peak itself. But this is probably the highest quality in the Jemez. But again, it comes in relatively small sizes. The largest I've seen is about the size of a cannonball. But still pretty big compared to what we see at No Agua Peaks. And given that it's better quality, we'll probably search for that. And then in the very center of the caldera, very center of this extinct volcano, are several obsidian deposits that are chemically identical. We refer to those as the Valles Rhyolite, or we can also refer to it as the primary hill on which it's found, and that's called Serra del Medio, Hill of the Middle. This is a high quality obsidian. It has few internal flaws, but to get to it, you have to hike up an extinct volcano, hike down into the caldera of the volcano, quarry your obsidian, reduce it down, and then hike it all the way back out. And as you can see on the map here, to get to the center of the caldera here, you're actually going to be walking over Cerro Toledo obsidian deposits, or if you come from the north, you're going to be walking over El Richuelos deposits. So you're literally walking over obsidian to get obsidian. What about this other material, the rhyodacite? There's not very well, I should, before I say that, there are some deposits of it around to the south, but the ones that we see up in the Taos area are predominantly to the north and to the west. There have been a number of different quarries that have been identified. And as you can see from this kind of the topographic relief of this map, these little hills, these are all volcanic vents. So at one point in the past, magma was flowing out of them, and that magma has now cooled and it forms this rhyodacite. In fact, most of those domes out on the plateau have some sort of nappable stone, even the ones that are not labeled. The ones that are labeled, though, I know that there are quarries there because my colleague and a former SMU graduate student, Jay Newman, went out and identified these in 1982, 1983, 1984, the time that this survey was going on. And he was actually the first to identify what is now called Newman Dome after his last name. These are fairly large, large blocks are available at most of these, so they're fairly, good sources for reliable big chunks of material. I don't know of any studies that have reliably evaluated the quality of it. So I can't tell you that Newman Dome of rhyodacite is better than San Antonio mountain rhyodacite. They're all pretty much, at least as I've mapped them, about the same. But San Antonio Mountain and Newman Dome have both been long kind of recognized as being important sources for folks in the area. As we'll see, probably good reason for that. So after we inventoried all of them, and we eliminated those sites where there were no lithic materials that qualified, they were not fine-grained volcanics, they were not obsidian. We set those aside, and we're left with 141 sites and 151 isolated finds, with a total sample size, the total number of artifacts of 650. 250 of those are temporally diagnostic projector points, ranging from what we would refer to as Plano, Midland, Angostura, all the way up to the historic period arrow points, little side notch, tiny little things. Now, the archaeologist that ran the survey and published on it in 1986 states in their article that fluted Clovis points were found during the survey. They may have been, but I have yet to find them in our archives. So if you have some underneath your desk, you know where they might be, please let me know. I'm very curious to find them. So the earliest that we have are some of the examples of those unfluted lanceolate points with a concave base that are being passed around what we would again call Plano style points. This is the distribution through time. You can see the different point types arrayed by age, from about 8,000 or so BCE all the way up to present. And then on the right-hand side, from your perspective, is a histogram showing the frequency or the number of points. So not only do we see this kind of exponential increase in the number of points through time, beginning with only 5 Paleoindian points that fit our criteria, but we end with about 290, 300 or so points from the earliest portion of the ceramic period. Now, this was, again, because I'm not a Southwesternist, I'm still learning a lot of this stuff as I go. I was a bit confused by why we have this sudden drop off at the very tail end down here. And it was not until I actually started kind of understanding what was going on that it made sense. And in part, it's because during that later portion, what's called the coalition period and then the historic period, is when Taos Pueblo and Picary's Pueblo, two existing pueblos where people still live today, were established. And they were established by the groups of people across the Taos Valley coalescing, hence the name, into these communities. And guess who didn't have permission to walk on Taos Pueblo land and pick up artifacts? The Taos Valley Settlement Survey. So in part, that reduction that you see at the end is not reflecting the number of people or the number of tools that would have been out there. It's reflecting survey bias. Nobody was allowed to go pick stuff up on their land. If we segregate or separate out obsidian and rhyodacite, this is what the samples look like through time. Again, we have a histogram, the total number at the top, and then just a simple line chart at the bottom going through time. And you can see that the frequencies, relative frequencies of rhyodacite and obsidian through time are relatively stable until the transition from the late Archaic into the developmental period. This is about the time that agriculture is introduced in the Taos area. This is also about the time that the bow was introduced in the Taos area. So that's kind of neat. We see some trends through time. We see a slight diversion where rhyodacite, after the introduction of agriculture and the bow and arrow, drops down, and obsidian really comes to dominate the assemblages. But we can do a little bit more. Again, I mentioned at the beginning that I'm a geoarchaeologist and I like to nerd out with chemistry a little bit, especially when it's chemistry of rocks. So what we did was we used X-ray fluorescence spectrometry, or XRF. And hands up if you had a chemistry class since high school. Okay. I'll keep it simple. This is the way I explain it to SMU students. No offense to SMU students, but I try to keep it simple. You got to remember that this is going to be posted on YouTube, and I'm just going to tank my teaching evaluations. So we bombard the sample with X-rays. We have an X-ray tube, we crank it up, and we shoot X-rays at the sample. If we all remember the kind of basic simplified depiction of an atom, we have a nucleus and we have a cloud of electrons orbiting around that nucleus, right? So that X-ray comes in and it knocks out an electron out of orbit. Well, for that atom to maintain charge balance, an electron from a higher orbital has to drop down to fill that empty space. And when it does, it has to put on the brakes. It has to give off a little bit of energy to slow down. When it does that, that energy it gives off is released as a photon, what we call an incident X-ray. So we have a little detector that measures that photon. And it measures the frequency, and it measures the energy of it. And using that information, we can determine what element that photon came out of. Iron, sodium, potassium, calcium, whatever it is. That's all yes?
Is that the same process that rocks fluoresce under ultraviolet light?
Is it the same process as rocks fluorescing under ultraviolet light? It is not. Rocks fluorescing under ultraviolet light is similar, but that's actually working at the mineralogical level. So the minerals are reflecting that light and fluorescing under that. Same way that if you go through the rock and mineral show, a lot of dealers will have a UV light over their mineral specimens because it makes them glow all sorts of cool colors. This is actually working at the atomic level, but it's similar in that when it's giving off that photon, it is actually fluorescing. If you had it in a controlled chamber in total darkness and you set up a camera, you would actually see little bits of reflects of light. So we analyzed all of these pieces that we brought back, all of the volcanic materials that we brought back. We analyzed them non-destructively. So we didn't actually break them or anything else. We just set them on our spectrometer, and the spectrometer is this little guy right here. When I first got to graduate school, we had a spectrometer that was about as big as this table. And in 15 years, they've now reduced to literally like a Star Trek phaser gun. Now, the big table-sized ones give you better data. They give you more precise data. You can quantify more elements with them. But if we're just shooting fine-grained volcanic rocks and obsidian, and we want to know the compositions of about 12 different elements, which tell most North American obsidian sources apart from each other, that little handheld phaser gun, or as my colleague Dave Meltzer refers to it, the flashy gun, that will work just fine. We shoot them for 90 seconds. Why 90? Because more than 90, we hit diminishing returns. Less than 90, the results are a little bit iffy. I create calibrations using internal standards and as well as international standards so that I can send my data to other folks that have XRF instruments and we can compare data. This is kind of the standard way of sourcing fine-grained volcanic materials today. Yeah, we could put them in a nuclear reactor. That's what I used to do in graduate school. And we'll get data. We'll get data for 34 elements, but really only those 12 are the ones that we need. And so here's the results for all of this big sample. 367 of these pieces of obsidian, or 71% of our sample, sourced to that El Richuelos source in the northern Jemez Mountains. 107, about 20%, sourced to that Valles Rhyolite, Serra del Medio, in the middle of that caldera. And probably the easiest source to get to and collect material from, Cerro Toledo, is the least represented. Only 41 pieces or 8% of our sample. So that tells us that people were walking over it to get to these other two sources. They knew that it was, if they spend all day making a Clovis point, and there was one of those little spherulites inside of it that they didn't see, and they struck it the wrong way, and the whole thing would blow up. Somebody had that experience and said to their son, to their daughter, "This is crappy stuff. Keep walking up the mountain, you'll get to the good stuff." And people listened. No Agua Peaks, remember that's the linear distance-wise is the closest. But it's also the poorest quality, is not even there. They knew that that was garbage. In terms of the Rio Day site, we see a similar pattern. Almost 89% of the Rio Day site artifacts sourced to one source, the Newman Dome. All of those other sources on the Taos Plateau, less than 10 pieces. Most of them less than 5 pieces. That's a really interesting pattern. Because we're talking about 10,000 years of people making stone tools, all condensed into one palimpsest in these graphs. And there's basically two sources that are making up everything. Yes?
What's the furthest point that you found away from this Newman Dome? To, I guess, get an idea of how far these people.
What's the furthest?
Yeah,
The biggest distance from Newman Dome to a source or to a site.
Like how far were these people traveling from to and from this dome to get the rock?
Distance wise,
Yeah.
less than 20 miles.
Okay.
But to get to Newman Dome, you have to cross over or under rather the Rio Grande Gorge, which is several hundred meters deep. So linear distance wise, it's not that far. But when you have to go to this gorge and zigzag all the way down, and then zigzag all the way back up, and then do the reverse with a bag of rocks, it becomes a little bit more difficult. We've actually tried to do like least cost path analysis to figure this out, except because we now have, since the 1950s, there's this nice new highway that goes across the gorge, nice beautiful steel bridge. If you ever want to look at it, just Google the Rio Grande Gorge Bridge. It's a beautiful work of engineering, but all the DEMs that every time we do it just goes straight across it. So we have to digitally remove that. And even then, it's easier, least cost wise, to go up and around or to go down and around and back up. So not that far straight line distance. But when we're talking about the topography that people would have been walking, it becomes immensely more difficult.
So if we're going around, how far would they travel?
Off the top of my head, I can't answer that question. I don't know. But
They were determined.
they were determined. And in order to get there, Cerro Negro, if we can go back a couple slides, let me see if I can work this. Let's go back. Ding, 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 ding. One more, there we go. So Cerro Negro is right here. You don't have to cross the Rio Grande. That's what this big cavern is that's running up through the valley. So to get from the Taos Valley here up to Newman Dome, one way is you're walking right past the source and you're saying, nah, forget about it. We don't want that. We know where the good stuff is. That's where we're going. If you go down and around, come down this way where it levels out a bit and then hoof it all the way back up, you're also passing several domes that may have rhyodacite, but that puts you right where the obsidian is as well. Yeah.
You mentioned the Pickers Pueblo. Is that Pickers Reservation?
So Pickeries is further south. Let's see, Pickeries is, is right here. So it's on the other side of this mountain. And then Taos Pueblo is right here.
Is that reservation land?
Yes, it's native land. Are the sources on, is that the question is, are the sources on the native land?
Yeah.
No. Newman Dome is on BLM land, and Cerro Negro, as far as I'm aware, is privately owned. Don't hold me to that second one because I haven't specifically looked, but I know where most of the native land is in the valley. And yeah. So let's go back up here. So we've got two sources, 10,000 years, two sources are pretty much making up everything. Let's look at this through time. If we take those diagnostic projectile points, if we assign time periods based on, if we go to a site and we pick up paleo points and that's all we pick up, and then there's some debitage with those, we're just going to assume for the sake of simplicity that the debitage is probably also Paleoindian. If we find certain kinds of ceramics, we can assign it to either the developmental or the coalition period or the historic period, if we don't have diagnostic points. And it's not as if one of these time periods is being dominated by all of the stuff from one source, and that's what's skewing our sample. In fact, what we see is that throughout time, both of those sources are the most dominant material, which is really bizarre. Bizarre for me because in the Northeast, where I've done most of my field work and time and my dissertation and my master's work, what you see is change through time. What you see is Paleoindians come in and they pick up a few key resources and they use those, but then as people settle into a landscape, they find new sources, they exploit those new sources, and you see a diversification of lithic materials through time. And maybe you kind of see that with the addition of a few of those two other obsidian sources. But you certainly don't see that with the rhyodacite. Siri doesn't understand. I don't understand either. Yeah.
Do they have remains of these natives through time to know if it's the same genetic people or if it was like people came, left, died off, the people populated it?
I'm going to say that the valley that all of this comes from is the ancestral lands of the Taos Pueblo, Pickeries Pueblo, and during the historic period, the Jicarilla Apache.
So the other Apache.
There's no clear evidence for a massive migration of people in or a massive migration of people out. And in fact, I would argue that the lithic data support this, because if you're coming into a new landscape, you're probably not going to continue the exact same lithic procurement pattern that the people who abandoned it 500 to 1,000 years previously did. There's going to be some difference, right? That's my idea. Maybe I'm not seeing something, but for all intents and purposes, I think the archaeology of the lithics, at least, is pointing to continuity through time rather than discontinuity. Does that answer your question? What about other sites? If you heard my talk in 2000, well, I guess last year, 2022, to the Panhandle Archaeological Society, I talked about some other work that we were doing. And during COVID, I also analyzed a lot of stuff from other sites that SMU had excavated during the 50s, 60s, 70s, 80s, 90s, and 2000s. And so what we see here on the bottom, this is a bit confusing, but I couldn't think of an easier way to show it. I'm not a graphic designer. But here at the bottom, these are pie charts of the data from the Taos Valley Settlement Survey, showing representation of obsidian sources through time, similar to the previous graph. And then stacked on top of it are data that either I've produced or that I've gleaned from the literature. So for example, Brad Vieira analyzed, did a similar kind of broad scale landscape survey in 2013 and did some obsidian sourcing, and those are his data. And then all of these stacked ones with the site numbers over here, these are data that we produced at SMU. And with the exception of Vieira's early archaic sample, which doesn't really seem to fit the pattern that we've identified, what we see is, again, remarkable consistency through time in terms of these are the three obsidian sources that are being used predominantly. And of those three, that El Rechuelos obsidian is the most popular. In a recent paper that I submitted about our results from LA 260 or Pot Creek Pueblo, the big Pueblo site that dates to the Coalition period on SMU's campus. One of the reviewers said, I don't know that you can really say that this is preferring a particular obsidian. If you're that reviewer and you're watching this talk, is this enough to say that people are preferring that obsidian? I think it is. Thank you. You want to go off your paper? It's fine. What about rhyodacite? Jay Newman, graduate student at SMU, first identified Newman Dome. It takes his name. He did some XRF of rhyodacite for his dissertation, so I've included his results. And again, Brad Vieira's work in 2013, published in From Mountaintop to Valley Bottom, added that in. And again, with the exception of his early archaic sample, what we see is that Newman Dome, in this case, the bright green, is again the most common source used through time, regardless of where we're looking on the Taos Plateau and the Taos Valley. Again, I think we can say people preferred this. They wanted it. It's a bit like choosing Whataburger over Wendy's if you're presidential candidates or whatever that hubbub was about a few years ago. So, at least across the Taos Valley, with this large sample, we see a decrease in time of the use of rhyodacite, effectively ending with the introduction of agriculture and the beginnings of permanent villages. At the same time, we see this effective increase in obsidian where it becomes the dominant raw material, again, of the volcanic materials. I don't have all the charts inventory yet. But at least of these two materials, obsidian becomes the most dominant one. As I mentioned a couple minutes ago, this happens with the introduction of agriculture as well as with the bow. That paper by Brad Vieira I mentioned, he makes the argument or puts out the hypothesis that maybe this has something to do with transitioning from the atlatl dart to the bow and the arrow. Rhyodacites, if you hold and you take any of those out of the bag that I passed around, they're harder, they're more durable, they're more dense. They don't fracture as easily. So maybe there's a preference for longer lasting, more durable tools when you're lofting atlatl darts. I don't know. This is a perfect scenario for the use of experimental archaeology. Let's go get some of this material. Let's make some projectile points. Let's haft them onto at-lattice darts. And since we're in Fort Worth, we can loft them at SMU. If we're over at SMU, we'll loft them over at TCU. But see how they actually perform under controlled experimental conditions. I don't have an answer for why this shift occurs. But I do see, at least in terms of where Native people on the Taos Plateau are getting their materials, a remarkable consistency through time. Not discontinuity, but continuity. Those two sources, El Richuelos and Newman Dome, it's found during the Paleoindian period, and people come back over and over and over again for 10,000 years. I would argue that those two sources, at least, are part of what we could consider to be the traditional cultural landscape of Taos area peoples, which kind of gets us away from thinking about individual sites, but thinking about how people that made and lived on those sites used the land and the resources on the land. And I think with a sample size now of in excess of about 5,000 pieces that we've analyzed from all of these sites, I think we can say that this was part of what they considered to be their land, where they lived. So I mentioned that this was a project I started during COVID. And it started in part because I was tooling around the lab and I needed something to do. I was going nuts. Same thing occurred with a group of volunteers that we have out in that had been coming into our Taos campus to inventory and catalog artifacts. COVID happened, they shut the campus down, and these volunteers, many of them were retirees, were stuck at home with nothing to do. And the kind of leader of this group of volunteers put together an interest group where they distributed articles once a week and they'd meet over Zoom and talk about them. And they invited me to give a talk about the obsidian from Pot Creek Pueblo, and I did. And over time, they kind of got sick of just talking about articles. They wanted to do something. And I was like, I have something for you guys to do. So I scanned in all of the site records, sent them to them so they're posted on the web so they can download them, and they're busily transcribing them each week. Maybe they only get 5 or 10 done a week, maybe 5 or 10 a month, but they're chipping away at it gradually. And we meet once a week to talk about problems, for me to express my gratitude for the work that they're doing. And then, once they got started doing that, this disheveled, bearded man walked into my office and said, "Hello, I'm Jay Newman." And I said, okay. And he said, "I want to volunteer. I just retired after 30 years working for the Army Corps. Can you put me to work?" And I said, "I can put you to work." And so Jay's been coming in for the past 4 or 5 months now and going through all of the non-volcanic lithics from the TDSS. Identifying, are they chert? Are they alabates chert? Are they something else? Measuring them, inventorying them, etc. And he, as of 2 weeks ago, 3 weeks ago, shortly before Christmas, had gone through all of the pieces that we brought back. And now I have to type all of this stuff into the computer because he's writing it down on paper. So we're working on it, mostly through volunteer efforts. And as I think a lot of people who are interested in archaeology want to do, there have been several folks in this volunteer army of people who have expressed an interest in going back and looking at some of these sites. We do field trips. And I don't see why not. As long as we have landowner permission, I don't want to get shot. SMU professor shot leading retirees to on private property, that would make bad news, right? But during the survey crews actually inventoried the 3 or 4 most common vegetation types at the site. And if you recall, none of this information was ever given to the New Mexico SHPO's office. So if you were gonna build a Walmart in Taos, and when did Walmart begin expanding and building mega Walmarts? Not in 1981, not until recently. And if they did an environmental impact statement, maybe they went down to the SHPO's office, they looked at, do we know of any sites in the area? None of these sites were ever logged. So if you're just doing a background review, you would never catch it. So how has the rapid urbanization of the Taos area, and it's become very, very popular in the past 20 years, how has that actually affected the archaeological record? This survey and the data here give us a really cool study that we can say, here's what happens when you don't log archaeological sites. Here's what we can expect if you don't review for those sites. And again, I started off mentioning how I feel there's this ethical obligation to fix these problems. Ultimately, everything that we're doing, we're going to write up. We'll submit it to SHPO. We're also going to write some articles. And you mentioned you don't have qualifications to be a co-author. It's not a problem. All of my volunteers are going to be co-authors on everything that results from it. They've done the work. They deserve it. So I should also thank Laura Wildman, who's an SMU student who began analyzing the obsidian here. She analyzed a substantial chunk of it. The Taos Valley Settlement Survey volunteer crew, Tammy Coyle, Jen Eloff, William Fawcett, Mark Henderson, who's kind of leading things. Mark is truly a great guy. Paul Krasinski, David Love, Susan McCarthy, John Martin, and of course, Jay Newman. I should also thank my colleagues at SMU, ISIM, the Department of Anthropology, and the Department of Engineering for giving me money to buy this flashy phaser gun to do this work. Because I don't have $40,000 that I'm going to spend on a laser gun, at least for SMU. But by pooling money from these different sources, we were able to purchase. And the original, as I mentioned towards the outset, the original TVSS was initiated by Ann Woosley, who was a faculty member at SMU, carried on by Jeff Gerard, who was at that time a graduate student, and the last survey season was done by Shirley Kuntz in 1988. That survey was funded by ISIM, Institute for the Study of Earth and Man at SMU, the Department of Anthropology, SMU and Taos, and a whole host of private donors. And I want to make sure that even though this survey was done and many of these donors are probably dead, that their names are acknowledged for funding this research. If you have questions or comments and you don't want to ask them right now, you can always email me. Even if you just want to talk about rocks, happy to talk to you about it. Otherwise, that's what I got, and I'll take all the questions you have.
Question. I know you're focusing on the obsidian rhyolite, but what percentage of all the lithics that you have, because obviously you have insurance and some of the other stuff, what percentage of the lithics are obsidian and rhyolite and of all the ones you found?
Sure. So the question, if you didn't hear on the microphone, is what percentage are cherts, rhyolites, et cetera, compared to the entire sample? The short answer is I don't know, because it's not, I'm not going to go through the index cards. But as I'm going through, as we were going through and pulling the obsidian, it was 50% or more. So it was a pretty substantial portion of the debitage from any particular site. Of course, there may be a whole, more boxes of rocks that I haven't seen. It's always the problem working with older collections that people haven't looked at in 40 years. Maybe there's some in a cabinet that nobody's looked at. Somebody put in there for safekeeping in 1989 and then left. Ask me again in a year. Invite me back, I'll tell you all about it.
Well, I appreciate, I was just going to ask you to please repeat the questions from in the room for the folks on Zoom. It's perfect.
Gotcha.
and wonderful talk. We have some questions on Zoom, so I'll let you know when you're ready for those.
Okay, he had his hand up real quick, but
Just a procedural data question. Well, first of all, don't go hurling anything at TCU if you are not like that. Second, what, when it comes to your data and, crunching data and findings, what program are you guys using? Or anything specific?
so I use R to do my data analysis. I occasionally use a series of statistical routines that were first coded by Hector Neff at the University of Missouri Research Reactor. Those are based on routines that were passed down from Brookhaven National Laboratories and the Smithsonian. But it's a pretty standard principal component analysis, canonical discriminant analysis, the standard set of multivariate analyses. Right. Is that? Yeah. And I didn't repeat the question. The question was, what statistical software are we using? And then there was a bit of a TCU SMU throwdown that was in there too. Yes.
So of all the obsidian artifacts you collected, you didn't find any obsidian sources outside of that valley area? Right.
Out of all of the obsidian that we analyzed, did we find any that went outside of the northern Rio Grande?
Yeah, there's no outside.
For the Taos Valley Settlement Survey, not one. At Pot Creek, we did. At Pot Creek, we published an article about it last year, reporting the initial sample of obsidian from there. We shot about 500 pieces or so, if I recall correctly. And 2 of those were from Obsidian Cliff in Wyoming, Yellowstone National Park. 1 was from Mineral Mountains in Utah. I believe 1 was from Grants Ridge in central New Mexico, but it was onesie-twosie kind of stuff. I will tell you that since this time, a graduate student has analyzed all of the remaining obsidian from Pot Creek, and we found more obsidian cliff and more of the same sources that were represented. But by far, the most is coming from the MS Mountains.
How do you explain the anomaly that Brad got in the early archaic?
How do I explain Brad Vieira's what looks to me like an anomaly from my perspective, my data or our data looks like an anomaly? I don't know. I don't have an answer. I suspect that his sample probably contains more stuff from the western side of the Rio Grande Gorge, but I don't know. This is something that I need to email him and say, let's hash this out and figure out why this is the case. How big is your sample? How confident are you in the XRF data that you have? And I think the XRF data look fine to me. I don't see anything that jumps out as incorrect about them in any way. So the question is, where does this stuff come from? And is this a sample of 5 pieces? In which case, probably not representative. So let's, that's a great question. We have to figure it out.
Hey, Matt, what about Hornfells?
Was that Tim Dalby asking
Yes.
that question? That was Tim Dalby. We have not encountered the question, what about hornfells? We have not encountered any hornfells in the TVSS collection as of yet.
It's there.
Well, come in, and you come into SRU with Jay, you can. Yes, sir.
Do similar studies exist for the location of the material that makes our ceramics? Or their pottery?
Do similar studies exist for determining locations of pottery?
There's long distances, or was everything local?
Right. There's one study that I know of that looked at chemical analysis of ceramics from the same area and found that most of them are being locally produced. In terms of ceramic styles, I can tell you that during that ceramic period, the developmental coalition, there doesn't seem to be a lot of trade or appearance of ceramics that look like they're coming from around the Jemez Mountains where that El Retuelos obsidian occurs. And so it doesn't appear as if it's a trade thing. I would favor currently the idea of direct procurement. People are going there intentionally to get it.
Ready?
Sure,
All
more,
right,
more
we've
Zoom
got
questions.
some in here. Now, Tim Dalby's added a few, so, it may be best if he chimes in on some of his questions. His first one was Newman Dome what? And, I think for those of us that know Jay, please make sure you're double checking his volunteer work first off.
It's a legend in his own mind.
He was invited to come and I gave him the Zoom link. So if he's chosen not to arrive, then that's not my problem.
He doesn't know how to do it.
So there's a question, what is the difference between rhyolite and rhyodacite?
So rhyolite is any rock that has a rhyolite composition. So the difference between that and rhyodacite, rhyodacite tends to be higher in potassium and sodium, lower in those elements, lower in silica, and tends to be dacite tends to be higher in calcium as well.
Phoenix.
And because of the cooling history, you'll see more mineral formation, oftentimes the formation or the resulting of phenocrysts or other things in the ground. Phenocrysts being small little minerals you can see when you hold it up to the light.
And Tim asks, were domes part of the Hopi Buttes volcanic field?
Part of the Hopi, were the domes part of the Hopi Buttes volcanic field? I've never heard of them referred to as the
Google 'em.
Hopi Buttes. I've always heard it referred to as the Taos Plateau volcanics. But that's a question that I don't have an answer for. So I would want to look that up before I commit myself.
Well, there's a whole bunch, if you go out I-40, there's a whole bunch of buttes or domes, whatever you want to call them, popping up through the Jemez Trend there. There's like 300 here and 400 there. And I think these domes are part of those.
They may very well be, though the Rio Grande Valley there is a rift valley, so it's highly active and constantly spreading. So you have a lot of these things that are erupting through time. So it
Yeah,
would-
5 miles northeast or northwest of Albuquerque, there's a whole trend line of domes and stuff like that for about 10 miles. And you can see them from I-40 if you look to the north.
I will look into it.
It's just a suggestion.
And Tim asks, would obsidian be found in the river gravels, in the river deposits there?
Obsidian is not found, to my knowledge, in the river gravels in Rio Grande, north of the caldera. And that's been fairly well surveyed in terms of going down and fishing out buckets of cobbles to see what's there. Now, there are a handful of small obsidian sources north of the border in Colorado. But that's a fairly chemically unique obsidian. And so if it was being used in any way, it would show up very clearly against the rest of it. And it simply doesn't. So, but south of the Jemez Mountains, south of the caldera, about where the Pueblo of Okeowinge is now, like I said, you can fish Cerro Toledo obsidian out of the gravels, clear down to El Paso and probably further. It's just, Tim Church did a study of the southern portion of the Rio Grande in 2000, and the limit of his southern study was El Paso, and he was fishing it out there. Now, if you guys want to go walk the Rio Grande with me today, south of El Paso, and fish out some rocks, that'd be cool.
Let's go.
I'm going to wear a flak jacket though.
Scott has a question. Did you find any non-local material in the project area such as alabates?
Any non-local material in the project area besides such as alabates? The TVSS, we do have a small amount of alabates that I've seen. Once I've transcribed all of Jay's notes and inventory in the computer, I'll have a better idea of that. I know at Hot Creek Pueblo and at Pickery's Pueblo to the south, there's a significant amount of alabates. In fact, those very typical large scrapers that we see for prepping of large game hides. We see quite a few of those. But for the most part, there's not a whole lot of elevates coming in early on that we've been able to find.
Another question from Scott. Why does so much Cerro Toledo obsidian show up in Texas despite being poor quality?
Because it's the easiest to get to. Just go to the Rio Grande. Is how I would initially probably argue it. Now, what's interesting to me, because again, you know, if you're walking across the Rio Grande and you see this black glassy material that looks like nothing you've ever seen before, I don't know about you guys, but I'm gonna pick it up. I also have way too many rocks at home that I pick up because they look interesting and I've never seen anything like it before. But it is certainly the most proximate source and the easiest to acquire to pick some up, even though it is poor quality. What's interesting to me is, and this is something I talked to Scott about, and when I talked to the Panhandle group about, is that at Pickery's Pueblo, which is basically the tail end. So after the coalition period, Pot Creek Pueblo effectively dissolves, and we only have Taos Pueblo and Pickery's Pueblo left. And at Pickery's Pueblo, based on what I showed you here, what kind of obsidian do you think we'd see in dominating at Pickery's Pueblo, occupied between, say, 1400 and it's still occupied? We find the El Rechuelos obsidian, except we don't. In a sample, and I've analyzed 2,500 pieces that were excavated in the 1960s from Pickery's, we have found 25 pieces of El Rechuelos obsidian, which is completely opposite what we see here. And that's at Pickery's. I don't know what's at Taos because it's at Taos, and there's not a lot of archaeology that's been done there. I know of one project that's been done there, and that was in the 1960s. But what's interesting is, up until about 1350 or so, on the plains, we see a lot of El Rechuelos obsidian, not a lot, but we see it out of the plains. It's not the most common, but it's present. After about 1350, you don't see any of it. I think there's maybe 2 or 3 pieces that I know of that made it out to the plains. So something happens that access to that particular obsidian seems to shut off at about 1350, 1400. I have ideas about that, but that's a whole other talk that I could go another hour or so. Yeah.
Can you tell by the color of the obsidian where it came from? I'm a plant knapper. I've got many pieces of obsidian. I've got blue, green, root beer color, the midnight lace that's clear with the black streaks to it. Does the color tell you where it came from?
So the question for those on Zoom, does the color of obsidian tell you much about where it came from? In some cases it can. There are some obsidians that are visually distinctive. There's a particular obsidian that occurs in New Mexico City that has this deep emerald green color. It has a gold sheen to it. Looks like somebody, when I was a kid, we used to go fishing and we would spray our lures with WD-40 because some guy told us it would help us catch fish. But it looks like it has an oil slick, like somebody sprayed WD-40. That's highly visually distinctive. Now the stuff in the Jemez, the El Rechuelos material, tends to be kind of murky, cloudy gray. Tends to be, but it's not all of it. The Cerro del Medio and Cerro Toledo obsidians are basically black glass. And some colleagues of mine have actually pointed out that at Cerro del Medio, in the middle of the there's obsidian that visually looks like the El Rechuelos stuff and other things. So there's mahogany obsidian, red obsidian, etc. So visually, it's a good first pass. Chemically, it'll tell you definitely. So if we had 50,000 pieces, I'm not going to shoot all those. They're 90 seconds a piece, no way. But we could visually sort them and then test our visual sorting through chemistry. So in some cases, yeah, visual criteria work. In other cases, not so much.
We have another question on.
If it's Tim,
This is Scott.
Tim knows where my office is. He can come in and talk.
What, this is the last one on Zoom.
Sure.
From Scott. So is Cerro Toledo acquired through direct access by local or non-local people?
Is Cerro Toledo obsidian acquired through direct access by local or non-local people in the Taos area?
Doesn't clarify.
My preference would be, rather than relying on the unknown vagaries of trade, unless it's substantiated by other materials that we can find, direct procurement seems most reasonable. I say that also knowing that a lot of the obsidian has cortex on it. So it has the tumbling rind from where it was being churned in the Rio Grande, or colluvium coming down off the Jemez mountains. And so if I'm trading stuff, or rather if I'm trading for obsidian, I know that that cortex has to be removed. So why am I going to be trading for pieces that have lots of unusable material? I'm going to want, something else. That's a bit on the speculation side though, because all I can tell you is what the chemistry of the obsidian says and where it comes from. The human processes of how it arrived where it is found are different. I do think, though, the sheer amount of Albertuelos obsidian that we find in the Taos area does not point to trade. That points to direct procurement. Does that answer Scott's question?
I think so. That's the last question on Zoom for now.
Okay. Anything else? I'm happy to stick around. I have a puppy at home who might be a little bit upset with me if I get home late, but otherwise, I'm happy to stick around.
All right. Thank you very much.
Now the question is, how do I get off it?
Yeah, I think we just have to hit exit here.
Let's see.